morning children. Coming to the class here. Again the same fourth chapter geometrical shapes. Yesterday I have discussed about the quadrilaterals, right? So in this quadrilaterals, as we already learned about the square, rectangle, parallelogram, rhombus, trapezium and kite, right? So up to fifth one trapezium I explained you, and from now the one more is added there, that is a kite. A kite means, as you already have seen, you people are familiar with this kite, you people play with that, right? So here the one more kite, it is also kind of a quadrilateral. You can see where it is having the four sides, right? So in this four sides you can see there, here, see here, actually it is the opposite sides. These two opposite sides are same and these two opposite sides are same. So here opposite way they according to this side and this side it is there. But when you go up and down as opposite, it is not equal, right? I will see the definition there. See, and we have angles also there, which are angles are found but which are not equal, right? It is a kind of a quadrilateral which has two pair of equal adjacent sides, right? Adjacent, I will explain you. Two pair of adjacent sides. Two pair means these two are equal and these two are equal, which is side by side, right? So side by side, whatever you say, that is adjacent, right? Adjacent sides are equal and unequal opposite sides. Unequal means these, if you compare these two opposite way, these are unequal with the angles, right? So here, based on this, we have two more topics here, that is adjacent. Adjacent means where you people are, see, you people are sitting with your friends side by side, right? So you people are adjusted to each other, sitting in one bench, right? You people will take care of yourself, right? So like that only here, here also, if it is side by side, these will be called as adjacent sides. This is the side, you know that, right? When it is side by side, it is called adjacent sides. Not only with the sides, also it is having the adjacent sides and also adjacent angles also you people are going to learn about that, right? As adjacent angles means this one, right? So next to this angle is there, right? So next to this angle means next to A the angle B is there, next to B angle C is there, next to C angle D is there. This is the angle, you know that this is this when you mark a arc and if you show that those positions will be named as an angles there, right? So like that, D, which is the adjacent angle for D? A and C. Means D is adjacent to the C also, A also, right? Side by side, right? So in that way, adjacent sides and adjacent angles are given. The same way, not only the adjacent sides and adjacent angles, you also have opposite sides and opposite angles. Opposite sides means you can see this one, right? So this is 2 mark which is given here length and this is single angles. You can see the length of the opposite way, right? These are opposite, right? Which are front of you, right? Those are equal. See, can you see? This is bigger and this is smaller. Are they equal? No. Excuse. So in that way, opposite sides are unequal. You can see this, opposite sides are unequal. And coming to the same way, opposite angles also. As we people are saying that opposite sides, and one more that it is about the opposite angles also. If you discuss the opposite angles also, you can see that this is little broader and here when you take it to the bottom, it takes a small position there, right? So opposite angles are also varied there, right? So but here these two are same, but the opposite way are not same. In the same, right? It is considered in the angles, right? When you are deriving it, people are knowing that, right? So here in this way, the kite also is defined. Also with that, you people are learning what is adjacent sides, what is adjacent angles, what is opposite sides and opposite angles, right children? Now based on this, as I said you that we will learn about the characteristics of quadrilaterals. As we are coming to the characteristics of the quadrilaterals, first I will the square, right? As you can see here, the square already we have discussed, right? All the sides are equal and all the angles are equal. Also, I already discussed in your previous class about the diagonals. You can draw the diagonals when the shape is equally divided. Means it is a regular one. Even the diagonals also will be equal to each other, right? Now, the square, the characteristics of this means this square also it can be known as a square, can be a special kind of rectangle, rhombus, parallelogram. How rectangle means? What rectangle says? Opposite sides are parallel, right? So if opposite sides are parallel, if you apply that opposite sides are parallel, even you can apply that also. Here also opposite sides are equal. As a square, you know that all the sides are equal. But still, if you apply the rules or the lines, whatever we have defined for these three, those three also can be applicable for this square also, right? So rectangle, even the square can be known as a rectangle, but rectangle cannot be known as a square. Now coming to the next one, a special kind of a rhombus. Also you can see here, this square also can be known as a rhombus, but rhombus can't be known as a square. What does the rhombus say? That all sides are equal and the angles are, opposite angles are equal. Here all the sides are equal and opposite angles are also equal, right? Whatever the defined term is there for rhombus, that can be applicable for this, but whatever it is there for square, it can't be said to this. Square can be said as a rectangle, can be said as a rhombus, can be said as a parallelogram, but these three cannot be said as a square. Fine. So here last one is about the parallelogram. In parallelogram, what you are saying? Opposite sides are parallel. Opposites. Here also opposite sides are parallel, and the angles are at the right angle. Here also the angles are at the right angle. So the square is also a special kind of a parallelogram. In this way we are seeing the characteristics. Now we will go for the next one. Okay, coming to the second one here, a rectangle. This rectangle also can be a special kind of parallelogram, as what opposite sides are parallel. You will see here in this one, the same way here also opposite sides are parallel, right? So here opposite sides you are going to see, but here we are seeing the parallel, means opposite sides are parallel here. So this is also a special kind of a parallelogram, where also the angles cut into the right angle and the diagonals also have the based on it. But diagonals are based on the rectangle, right? The shape given here. Okay, fine children. Now coming to the next here. Okay, coming to the next third one here, parallelogram. In a parallelogram, here also you can see that we have opposite sides are parallel, and this is also a special kind of trapezium. What trapezium says? Trapezium says that two sides are parallel. Means the opposite sides are parallel here, right? So you can see that in the trapezium two sides. That definition if you apply here, the two sides are parallel. Any two sides if you take that, those are parallel. So it is also called as a special kind of a trapezium. Coming to the next. Coming to the fourth one here, rhombus also a special kind of a trapezium, as we already discussed about that. Trapezium is the only two sides are parallel here. The other two sides are not equal, and the angles, as we have seen, the same here also here. You can see all sides are equal, but we can apply the trapezium definition to this also. Two sides are equal, and also we can see the diagonals are equal here. So, and one more point, rhombus bisects at each other at right angle. What are the diagonals you are drawing here? These diagonals are bisecting at the right angle, that is 90 degree, right? And those diagonals are equal. As we have seen in the square and the rhombus, both the diagonals are equal here. And other than that, now fifth and sixth are the trapezium and kite. I discussed you about this definition and the figure here. These two are not any special kind, only they are quadrilaterals. We are not comparing any of the quadrilateral to these two. Only these are called as a kite and trapezium. And coming to the page number 106, we have a tabular column. You can see in your textbook here, and you have to fill that blank and you have to upload to me as a homework for you to do it. Okay, coming to the next one here about the polygons. A closed figure which is having a line segments. By using a line segment, whichever your figure you are drawing, by closing it, that is known as a polygon. You already learned in your previous class. And next in that we have a regular polygon and irregular polygons. Okay. And regular polygons, what you are going to see here is where all the sides are equal. Means whichever, for example, you can take a square or a hexagon. Whichever example you can take, but all the sides should be equal. Right? For example, I have taken square, triangle, hexagon. Means triangle means equilateral triangle you can take here, right? Because which all the sides are equal. So a polygons which has a line segment when all angles and sides are equal, that is called a regular polygon. And irregular polygons means a polygon which is not having all sides equal, means it is unequal sides are. Anyway you use a line segment, a closed figure and draw it, which is not equal. equal. A polygon which has 9 segments where all angles and sides are unequal. So these are the diagrams you can see here, examples. These are called as a polygons because they are closed and they are made up of 9 segments, but they are not regular, they are irregular polygons. Coming to the next topic is about the 3-dimensional shapes and 2-dimensional shapes. As you already learned about this 2-dimensional and 3-dimensional in your previous classes, 5th class, right? So, in detail I am telling you here, it is about the 3-dimensional 3D shapes, right? As you know, it is known as the solid shapes, right? You people learned about that length, breadth, height of those shapes, right? What are those examples also you people have studied in your previous class. 2-dimensional flat shapes which are drawn on a plain paper or a plain figure where you are drawing it, right? But whereas this, you people are observing it. You can touch and you can observe what is there in that, right? In that way, these shapes, solid shapes are learned, and the 2-dimensionals are learned by drawing on a paper or a plain figure, plain surface. Okay. Now, in that 2-dimensional shapes, what are the examples you already seen? Once again, we will see here. Triangle, square, rectangle, or all the polygons you can take, circle, semicircle, so on you can take. Or what are the shapes you already know about that, right? So these all are about the triangle, 2-dimensional shapes. So where people are seeing the length and breadth of that, right? Means what will be the length, how to draw that, and what will be the space taken breadth, that you people are going to see there. Right? In this now 3-dimensional shapes, so what you are going to observe is how you people observe what is the length of that, what is the breadth of that, and also the height of that, right? So examples are in this way. These are also called as the solid shapes, like a pyramid, as we have discussed in your previous class as examples, but still once again I am telling you here. Pyramid is already seen that the example, the Egypt places there, and the next prism, where it is used for experiment purpose, right? So in that we have a triangle based prism and the square based prism we have here. One the base will be the triangle, the other will be of the square based. Okay. Then other than that we have a cuboid, sphere, cone, cylinder. Means as for a triangle, if you people are going to observe in a 3-dimensional, it will be seen in a prism way or a pyramid way, right? And the square will be seen in the cube formation for a 3-dimensional. And for a rectangle, it is called a cuboid, and other than that, as a circle, it is a sphere. So all the examples are compared here, right? In this way, these examples are seen. And for these examples, some more 3 options we are seeing. Then what is that? Okay. As we have seen this 3-dimensional shapes, right? In this 3-dimensional, so these kind of shapes we can see here, right? Where it is called as the triangular prism or a pyramid, you can say, square-based prism. And here cuboid, cone, cylinder, sphere, right? So in this you people are learning the 3 concepts about vertex or corners, you can say, or the face and the edges, right? So these 3 are you people are learning. Means as I said you can see, observe here, I have made some colorful here. Means which is in yellow color, those are all called as a vertex. Means where the 2 line segments or the 3 line segments are joining, right? So at that point, that dot or the corner will be known as a vertex, right? So how many vertices are there in a cube or cuboid? Whichever the example is given, based on that you have to find and you have to write, right? And for example, if I take a cube, in a cube how many vertices are there? You have to find. Next, coming to the faces, right? You can see the purple color wherever I mark, right? This is the bottom and the top and the side way, left and right, and the front and the back, right? How many are? Top, bottom, front, back, left and right. You got the 6 faces are there, right? It is about the faces which is written in a purple color. Fine. Next one more is about the orange color, that is edges. Edges means the side length of that, which is cuts in L shape, right? You can see that. That will be called as the edges. And how many edges are there? You have to find it. I'll show you one example. The other examples you can try in your home. See, I have a chalk box here. And it is in a formation of a square, means the cube, right? So you can see this cube. For example, this is the box, right? It is a 3-dimensional where I can touch and I can observe, where I can feel it, right? So it is a 3-dimensional. All the sides I can see, the length, you can see the length, right? The breadth, what is the breadth here, and the height of that, right? So all the 3 dimensions you can see here in this. So based on that, I am going to check for the tube. How many vertices are there? How many faces are there? How many edges are there? Right? We will see that. Okay. Now you can see here, right? What I said you that where the lines are joining. This one line, this one line, this one line, right? All the three lines are joining at this dot. That dot is called as a vertex. So how many vertices are there? You have to see it. Now if I see from here, 1, 2, 3, 4, right? Top. At the bottom, 1, 2, 3, 4. Means 4 plus 4, 8. Means how many vertices you got there for this? Vertices are 8. Right? So 8 vertices you got here. Now we will come into the next faces. How many faces are there? You can see here the top one and the bottom. 1 face, 2 face, and the right and left. 3 face, 4 face, front and back. 5 and 6. So you got the 6 faces. And now coming to the last one, edges. As I said you right, it comes and it cuts in this way, L shape, right? So those are the edges. How many are there? 1, 2, 3, 4, right? Next, 5, 6, 7, 8. Because 4 sides are 9, 10. And coming on to the one more with the top, 11, 12. So 12 edges are there. You get that 12 edges. Coming to the next now, one more. Here, I will show you here. See, here, edges. Once again, I will show you here. Edges, don't get confused with that. We have a 12 edges, right? For this cube, right? 1, 2, 3, 4, 5, 6, 7, 8, right? 9, 10, 11, 12. Top 4, bottom 4 and side way 4, right? So you got a 12 edges. How to find the edges? I hope that you understood that, right? In this way, which cuts in L shape, right? Those are the edges here. So 12 edges are there. So now, as your homework here in your textbook, here it is given there. The table it is given here. In the page number 110 it is given there. You can see there the fill up the blanks is given based on each example. So you take any example of that from your home or any instrument or a thing, you take that and try this. Find out how many vertices are there, faces are there, edges are there from the page number 110. You try and do it the homework here, right? These are the examples for the three-dimensional shapes. Okay, children, this is all about the chapter 4, geometrical shapes. This is combination of the 4th and 5th, right? So here I have explained you the concepts now. Next we are coming to the exercises. As based on the concepts, I will give you the exercises, and on basis of that you can complete your exercises, children. Fine. And this be clear here